the zinc is being
That looks
oxidized.
like oxidation to me.
So this is called the anode, and this is called the cathode. By the way, the anode has a negative sign, so if we had a battery, and the cathode is positive, because cats are good, or that's how you can know that cats have a cation.
I like cats.
Yeah, I don't actually, but that's another story. They
You're a
make me
dog
itch.
person. Oh yeah, that's right.
Have
Allergic.
mercy. Now, we still haven't completely labeled this. There's still more to do.
Salt bridge.
What about the salt bridge?
It needs a name.
All right, so let's label salt bridge. Now, since we're actually using the electricity, the electrons have to be traveling through the wire. What is the direction
They
of the
go
electron?
from the anode to the cathode. Gosh, I can't talk to the anode.
They go-
From the anode to the cathode.
You can't talk, the man has bad accent, he must learn to speak English.
Exactly.
Oh my
And
gosh.
it makes sense. If you look at the equation down there, we're producing electrons in the anodes. So
Right.
then they're going to go to the cathode where we're getting the
You see,
electrons.
yeah, the electrons leave the zinc cell, and the copper wants them. But of course we have a problem. As the electrons flow into here, it's
Yeah.
going to cause the charge of this side to become more negative. And so to counteract that, what's going to happen is through the salt bridge, you must have negative things flow this way. So these will be called the anions in the salt bridge. Now when I say the salt bridge, typically we'll put like sodium nitrate in there.
Yeah,
so
something
in this
that's not gonna
case,
react.
the nitrate ions would flow through here, actually through here
Yeah.
to there. And then conversely, actually, your cat ions
Yeah, sodiums are going to come that way.
are going to come this way because it equalizes the charge. So you can see this is a very, very busy picture. What are the kinds of typical things you're going to be asked to solve for? Okay, the kind of things they're going to ask for is direction of electron.
Yeah.
Direction
of electron flow.
Now I can't talk. D-I-R-E-C-T. Direction of flow of electrons. Also direction of electrons. Direction of flow of cations.
Or anions.
Or anions through the salt bridge.
Or which side is the anode, which side is the cathode, things like that.
So there's lots of questions that you'll be asked on tests, on the AP tests, whatever. They love to ask questions like that. It's just common. All right, the table. All right. Now, how do we actually use this big fancy table that we looked at? All right, the table above, the one that's in your handout, assumes that you have a
1 molar solution.
So when we said it was 1 volt, that assumes that it's a 1 molar solution.
So I guess my little soda pop battery here probably didn't actually produce
and also
that.
1 ATM and
25 degrees Celsius.
25 Celsius. So we're really not at these conditions.
Nope.
But that's what the table assumes. Later on, in a subsequent podcast, we'll learn what to do with when we have different molarities and different temperatures and such. Okay. So now let's just use our table. A little practice. You'll find that the table is very, very, very important in your class. Okay. So the first one we have Na is going to Na positive.
Yipper.
Plus 1 electron. Now what I basically want to do is I want to go to the table. And
Yeah.
if I go to the table, I can find out what the sodium what is the exact
It's in the word.
it's in the second
There
one.
you go.
All right. So we need to find sodium.
Sodium, there it is.
And look at the voltage. Now it's 2.71 negative.
And that's for the plus ion to go to the metal.
So this one is flipped, so it's going to be
Positive.
2.71. You guys see what I did now? Look at your table. If you don't have your table out on your packet, this is going to make sense. That's in voltages. We haven't learned what volts are. We'll learn later. And the PbO2 is going to Pb plus 2. Now, we don't have the whole reaction, but guess what? Instead of me trying to sit here and balance that equation,
Let's just go find it.
let's just go find the reaction.
Pb. Ooh.
Mr. Sams, is this it
I
right
got
here?
it right there. Yep.
And there's the reaction. The voltage is?
Negative.
Is it written the correct
0.5.
direction?
It is. That's the way we're going.
So it's
Oh wait, you know what? That's not right. We want PbO2. That says PbO.
Oh
Uh-oh.
my,
Oh,
Mr. Sams.
almost.
So we take a moment and try and
Let's
find
find
the
another one.
PbO2. I be PbSO4 over here. No, that's
No,
not
that's
it.
not it.
We'll find it. Okay, we find. Of course, we're using a table that may not be from the old
Yeah,
podcast.
I think this came from Wikipedia.
It did. We're trying to save. There's a PB one, but that's not the right one.
Where's PbO2?
We'll
Oh
find
wait,
it.
is that it? What's that alpha?
I don't know why we have alpha.
And there's a beta right above it.
It's
But they're both close enough. We'll
1.4
call it 1.5.
1.5. All right, there it is. We find. All right, so it's 1.5, and it's already written, and this is 1.5 volts. Okay, so what's the total voltage?
Well, we want it to add up to positive.
You know, we should probably write the whole reaction.
Yeah.
So let's do, it makes plus 4H positive, all right?
Yep.
So I'm just copying it from the other table.
Plus 2
Plus
electrons.
2 electrons, so I'm just flipping back and forth, makes plus 2 waters on this side. Now, when we add these, though, so we have to multiply this by 2, so the overall reaction, right, would be 4H positive. We'll have to double the top one, plus the PbO2, plus 2Na, makes 2Na positive, plus Pb2 positive, plus 2 waters.
Yep.
So I have this 2 here.
Yeah.
Do I have to do anything with that?
Well, we distributed it through the equation, but do not confuse this with your thermodynamic stuff.
Yeah, folks, this is a common mistake. If
Right.
this 2, oftentimes we think we need to multiply this by 2.
You do not do that in
No,
electrochem.
no, you just add them.
Yep, just add them up.
And I could get 4.3 volts. This will make a pretty strong battery.
Yeah.
4.3 volt battery.
That's a lead battery. That's what they put in cars.
There you go. That's probably why. All right. And then let's do this one. So I have Fe plus 3 goes to Fe plus 2. We probably don't need to look this one up in terms of balancing.
Yeah, we
balancing. So
better
let's
get
go
that one.
back to our
Yep. Now
our
be careful
table.
when you look these ones up that have multiple oxidation states. Make sure you get the correct one.
Yeah, because Fe2 to Fe3.
Yep. We're looking. Okay, see, this is not it. This is Fe2 plus becoming Fe metal, so that's not it. We got to find the one that has the actual numbers that we're
Yeah, we
looking
don't
for.
like that one. So yes, Mr. Sam's found an Fe2, but it's not Fe2 to Fe3. I don't see any Fe's. It's going to be on the busy
it's going to
page.
be in the big mess one. Oh, there it is, right there.
Mr. Sam's has got better eyes than me.
And I just had my eyes dilated. I must be getting my vision back.
Ah, 0.7. Now, to go to Fe2 is 0.77.
Yep. Positive 0.77. I think that's what we have. Yep.
So this is positive 0.77 volts.
There it is.
And then we go to Mg, to Mg, 2 positive, plus 2 electrons. And if you don't like that table, guys, there is a table in your book
Yeah.
that you can also use.
Right.
So Mg to Mg2 positive is going to be at the top of the list. I'm not mistaken.
Yeah.
First
I remember
page.
seeing it too. There it is.
So it's going to be,
Negative 2
but
point.
it's flipped,
Yep.
so it's
gonna be
2.4.
2.4, but it's going to be positive because it's in the reverse.
Yeah, because it was negative and I flipped it, right?
Right.
And so the total voltage would be 3.17.
3.17.
And the overall reaction, you would have to double this,
Yep.
and it would be 2.
But that still doesn't change the
Fe
voltage.
does not change the voltage, plus the magnesium makes the magnesium 2 positive plus the Fe 2 positive. So if you were to separate these in a cell, put a salt bridge between them, and put a voltmeter between them, you would have a voltmeter that would read 3 volts. Now, you've got 9-volt batteries, though. How's that possible? Actually, if you thought, what would be the best battery that you could possibly make with this table? If you think about it.
Yeah, well, we'd want to take
You would take the lithium, that'd
Yep.
be 3 volts.
with the cesium,
And with the one at the bottom end,
the most positive, yeah. Well, but we're going to have to flip one of them.
well, yeah, just take the most negative and the most positive, and then you'd get about 6 volts.
Okay.
Because this is 3 volts
Yep.
positive, and if you flip this top one,
Yeah, oh, yeah, I see what
you would get
okay.
another 3
Yep.
volts, so about 6. But I've heard of 9-volt and 12-volt
Yeah.
batteries. How's that work?
They just take smaller cells, they hook them up in series.
Yeah, they actually hook them together. So if you have a 3-volt battery hooked with another 3-volt battery with another 3-volt battery, well,
Then
then
you
you
have a 9-volt
then you have a 9-volt battery. So it's actually very, very uncommon to have a cell, a galvanic cell, with more than a couple of volts.
Yep.
So this would actually be a relatively large one that we have right here
Yeah.
with 3
And your
volts.
9 volts actually have 6 1.5ers in them.
Yeah, they actually have several cells. All right, now we've a couple more examples here. Now, can this happen? Now, when you're doing these problems, as you watch the Answer podcast, the key thing on these, is such and such capable of reducing such and such, is you're trying to get a positive voltage.
Yep. If you get a positive voltage, it's a spontaneous reaction.
And it happens.
If you don't,
You don't.
You don't.
So now we do hydrogen. Hydrogen, and Mr. Sam's alluded to this a little bit before, but hydrogen is an interesting part of the electrode. I don't have to look this one up. I know it off the top of my head, but here it is right here, and it's bolded on your paper. But the hydrogen electrode is 0 volts. It is sort of the standard.
Yes.
It's upon which everything is measured. So basically, you're going to have the hydrogen. This is 0 volts. So if I want to reduce the silver, that means I'm taking the silver to reduce it. You're taking it down to a lower charge, and the only lower charge you've ever heard of is 0. So I'm looking for, on the table, I'm going to look for Ag to Ag0 and find out what its voltage is. And I think it's up high. No, it's down lower. Because I think it's positive. I know this.
You're right.
Here's an Ag. It's not the one I want.
Nope. Oh,
Here it
right
is.
down. Oh,
Isn't it?
you're right. Yep, you're right.
It's about 0.8 volts.
Yep, 0.8 positive volts.
So it's 0.8 volts. So if it's 0.8 volts,
That's
is that
positive. That's spontaneous.
Bingo.
It's
Done.
gonna happen.
So that's how we can know that. Just looking for positive voltage. Let's do one more.